the first star the James Webb Telescope will see. We're looking at things that have never been seen before in the deepest fields of view of any telescope. So it's not only the first star, but it will be the best star, the one that will help us understand how stars form and how galaxies form and evolve. And that's not just going to be a scientific breakthrough, but it will change what you know about the universe we live in. It's that important. Hello guys, welcome to our YouTube channel Space Discoveries, and we are here with another interesting topic related to JWST. Let's get into the video. Here's everything you need to know about. The James Webb Telescope is being built by the National Aeronautics and Space Administration, NASA, and will be used to observe the first galaxies, formed after the Big Bang 13.6 billion years ago. It will also study new planetary systems and look for signs of life on exoplanets, along with many other things. It is launched in December 2021, and it is expected to be operational that same year. It will last at least 5 years before being decommissioned in 2025. The James Webb Telescope, or JWT, is the next generation of space telescopes that will seek out new discoveries and see the deepest into the universe than ever before. Unlike its predecessor, the Hubble telescope, which captured beautiful images of the cosmos but didn't have the capability to capture much scientific data about them, the JWT will be able to capture more than just an image of distant galaxies and stars. It will be able to capture their composition and movement as well. First of all, let's know what exactly this JWST is. What is the James Webb Space Telescope? James Webb Telescope, or JWST, is a large and sophisticated space telescope that NASA has spent almost $9 billion to develop. The telescope is named after James E. Webb, who was NASA's administrator from 1961 to 1968. The Apollo program got its start during his tenure. The JWST is intended to be placed in orbit 1 million miles away from Earth, much farther than any other observatory has ever been. That means it will have an unobstructed view of deep space without interference from our planet's atmosphere. It will also be able to detect infrared light, which means it can observe some of the earliest stars and galaxies in our universe. Simply, the James Webb Telescope is a telescope that observes light coming from stars and galaxies. It was announced in January 2018 that it would observe its first star in 2022. The James Webb Telescope is being built by NASA, and other scientists have helped build it too, including Canada, Europe, and Japan. With these scientists working together on one project like the James Webb Telescope, hopefully can help humanity learn more about space and space weather. This telescope should be able to observe things such as planets around other stars, black holes, and even some supernovas. Can it really see all the way back to the first star? Let's break it down. It's a big universe out there, and we don't mean just everything we can see. There are hundreds of billions of galaxies, and each one contains hundreds of billions of stars. The James Webb Space Telescope won't just be looking at individual stars. Rather, it will look to detect light from when they formed more than 13 billion years ago, as well as light from more recent exoplanets that host life. In other words, it could answer some of humanity's most important questions. How did our solar system form? What is dark matter? Are we alone in the universe? For JWST to do all that though, scientists need to know exactly where and how much light to expect from those early stars. And for that reason, astronomers have chosen what is known as an astronomical standard candle for their target: hydrogen gas clouds located near our galaxy center. These clouds emit radiation that allows them to be used as yardsticks for measuring distances across space. We want to measure something very precise about these objects so we can calibrate the telescope over many orders of magnitude in distance. If you had a ruler with 100 divisions on it, you would need to know that every division was 10 millimeters apart. So if you measured 10 centimeters and found that 2 of your divisions were closer together than expected, you would know your ruler was off by a factor of 10. Astronomers use similar techniques today to calibrate telescopes, such as Hubble and Gaia. Knowing precisely how far away objects help us understand their actual size or brightness. They're like little rulers in the sky. By understanding how bright they should appear, we can figure out how bright any object should appear based on its distance from Earth. This method has been used before, but never before has anyone tried to take measurements using an instrument as powerful as JWST. With its 6.5-meter mirror and infrared capabilities, it will be able to pick up faint light coming from distant parts of space that previous instruments couldn't reach. To get a sense of just how powerful JWST is, Consider that even at its farthest point, from Earth 932,000 miles away, it will still be able to make measurements 10 times sharper than Hubble. Its primary mirror also dwarfs Hubble's 2.4-meter one. Because of its larger surface area, it will collect almost 7 times more light than NASA's famous orbiting observatory. When it launches into space, JWST will be folded up inside a cargo bay of a European Ariane 5 rocket. Once it reaches its destination, 1 million kilometers from Earth, where it will orbit around the Sun, astronauts will unfurl its sun shield and robotic arm to prepare for observations. After a series of tests, it will be ready to begin its mission. JWST will observe an infrared light, which is invisible to our eyes. But that doesn't mean we can't see it. In fact, you can see a lot of things in space without visible light. Our own Milky Way galaxy looks completely different in infrared than it does in visible light. We wouldn't know that stars are forming there if we didn't observe them at longer wavelengths. JWST will be able to see objects that are too cold to radiate visible light, and it will be sensitive enough to detect light from objects that are billions of light years away. While Hubble is good at making measurements in wavelengths we can see, JWST is going to be really good at making measurements in wavelengths we can't see. It will allow us to explore a part of space we've never explored before. Conclusion: the James Webb Telescope is likely to make its first light-collecting observations within days, not years. The Earth will orbit into view of James Webb's successor to Hubble, a space observatory designed to peer deeper into space than ever before, allowing scientists to watch galaxies being born and study planets forming around other stars. The year-long deployment phase has been more difficult than expected due to several problems with testing and integration. After 2 weeks of checks, including vibration tests, at Goddard Space Flight Center in Maryland, JWST will be ready for science operations. It will be able to look back through 13.5 billion years of cosmic history, seeing objects as if they were just 400 million years after the Big Bang. It also can detect objects 1/10 as bright as those seen by Hubble, which launched in 1990 and is nearing retirement after making groundbreaking discoveries about black holes, dark energy, and exoplanets. The James Webb Telescope will also be able to look at distant galaxies, which may contain planets that could support life. Scientists are hoping that with their new technology, they can find evidence of alien life or maybe even extraterrestrial civilizations. Some astronomers think that there could be thousands of Earth-like planets within our galaxy alone, so we might not be alone in our universe after all. What are your thoughts on this? Let us know in the comments below. And most importantly, if you want to be updated on every single topic related to space, then you should consider subscribing to the Space Discoveries and pressing the bell icon. Thanks for watching, and see you in the next one.